Okay, there are two important things in the charging and discharging of capacitor, and they are called charging time constant and discharging time constant. Charging time constant and discharging time constant. First I will define the charging time constant. The time taken by the capacitor to fully charge is called charging time constant. Time constant. And this charging time constant is given by this value RC. As we know that the capacitor is charging through the diodes, so this R will be the resistance offered by the diode. Because once current flew through the diode, then this capacitor will get charged. So it means that this R will be the resistance offered by this diode. And we have another factor which is called discharging time constant. Discharging time constant. And it is defined as the time taken by the capacitor to fully discharge. It's called discharging time constant. As we know that once this capacitor start discharge, then it discharges through the load resistance RL, because the current is flowing through the load resistance. So the discharging time constant is defined as RL times C, where RL is the load resistance. Now, to reduce the ripple in the output of this rectifier, we normally use a capacitor with large capacitance, because the charging time constant, which is RC, will be smaller. So the capacitor gets charged in a very small interval of time, very rapidly. But the discharging time constant depends on the load resistance, which is high, and also the capacitance is taken to be high. So the time taken by the capacitor to fully discharge is large. So it means that this will reduce the ripple component of AC present in the output of this rectifier. And this capacitor will maintain current through L by discharging itself and thereby reducing the ripple. Also, the time duration for which current flew through LS through this load resistance RL increase, then the AC component of the output will be reduced. Like if this discharging time taken by this capacitor, the discharging of capacitor start from here and it discharge till this point. If this is large, then this curve will be flattened, more flat. If this is small, then this will be more curved. So greater the discharging time constant, smaller will be the ripple in the output of this filter. Now here I will draw the same figure again. Like initially the diode is forward biased, the capacitor gets charged and then it discharge. The capacitor D1 become reverse biased. So I will discuss this figure now in more detail here. At time t is equal to t1, like the charging of capacitor started from here. The time at time t is equal to t1, diode D1 start conducting, because diode D1 is forward biased, and it will charge the capacitor to peak value of the output voltage, to this value. The charging of capacitor continues till time t is equal to t2. Like the charging of capacitor started from time t is equal to t1 to time t is equal to t2. At t is equal to t2, capacitor charged to maximum value. Like up to this point, this capacitor charged to its maximum value. Now the plate carrying positive charge of capacitor is connected to inside of the diode D1, so it will reverse bias the diode D1 at time t is equal to t2. I'm not going back to the circuit diagram again. At the same time, diode D2 is already reverse bias, because this is the first positive half cycle. In the first positive half cycle, D1 is forward bias and D2 is reverse bias. But beyond this point, the diode D1 also become reverse biased. Now the capacitor get discharged. The capacitor get discharged through the load resistance RL and maintain current there. From t is equal to from T2 to T3, like from this time to this time, that is from B to D, capacitor discharge slowly, because discharge time constant is large to flatten the curve. During the second half of the rectifier, D2 is conducting and D1 is non-conducting, but diode D2 will be forward biased or conducting when time reaches to t is equal to T3. At t is equal to T3, diode D2 become forward biased and it will start charging capacitor. The charging of capacitor continues till time t is equal to T4. At time t is equal to T4, like at this time, capacitor charged to its maximum value. The plate carrying positive charge is connected to the inside of the diode D2, so it will become reverse biased away from this point. At time t is equal, while D1 is already reverse biased in this second half of the rectifier output. Now the capacitor gets discharged again. This is the discharging of the capacitor. This is the charging, discharging, charging, discharging. And this discharge is through the load resistance RL, and which maintain a constant current in the output. From time T4 to T5, capacitor discharge slowly. By this way, capacitor filter operate through the entire cycle of the rectifier output and provide a ripple-free voltage, a current. It provide a ripple-free, almost ripple-free voltage, a current to the load resistance. Now here I will find out the ripple factor. Now here we have these represent the ripple now. So here this region is the ripple voltage. It's represented by VR, this whole, because the ripple are this one. Before the ripple was this one, before the filter. But now after passing through the filter, the ripple reduced to this one. So VR is the ripple component of the output voltage. VR is ripple component of output voltage. And VDC, this is the DC voltage of the output voltage, DC voltage or DC value of the output voltage. This represents the DC value of the output voltage, this line, the central one. And this VL maximum is the maximum value of the output voltage. It's the maximum value. The maximum value is this one, this one, this one. So the region between the top and bottom line represent the ripple component after passing through the filter. The central one represent the value of DC voltage, and the last one represent the maximum value of the voltage across the load resistance. So VL means load resistance and maximum means maximum value of the voltage. Now from this figure we see that VDC, this VDC, this is the VDC, this is equal to this maximum value minus this value. So we have V maximum minus, now this whole is VR, so this will be half of this VR, so VR by 2, so it's VR by 2. Now I suppose that charging time from T1 to T2 is, let charging time, I call it equation 1, charging time from T1 to T2 is, I call it capital T1. And similarly discharging time from T2 to T3 is T2. Like this is the charging time which is between T1 and T2, I call it T1, and the discharge start from B to D, it's from T2 to T3. So from T2 to T3 the discharging time I represented by T2. Now during charging, charges will be gained by the capacitor, and during discharges charging will be lost by the capacitor. So the total charge lost during discharging is, total charge lost during discharging is we call it Q discharge, total charge lost during discharging. I simply represent by QD, which is equal to the current flowing through the output voltage, output load, through the load resistance time T2, because we define current is equal to charge per unit time. So charge will be current times time. Now the charge discharge, the charge lost during the discharging will be the current flowing through the load resistance time times the time taken during this discharging. So discharging time is T2. This is equation number. And the value of charge gained by the capacitor, charge gained by the capacitor, which we call it charge Q, charge gained by the capacitor, I represented by QC, which is equal to the capacitance time the ripple voltage, because we know that charge on a capacitor plate is equal to Q is equal to C times voltage across the capacitor. Now the voltage across the capacitor is the ripple voltage and C is the capacitance of the charge. So this is, let's say, equation number 3. Now I will proceed further in the next video.